Force and Laws of Motion, Part 6, Newton's second law of motion. In the previous video, we have studied how momentum depends on the mass and the velocity of a body. The momentum is greater for a moving car compared to the momentum of a stationary car. And in case of two balls moving at the same velocity, momentum is greater in the case of a heavier ball. Based on these observations, if you would like to change the momentum of a body, what Newton says is we need to apply force on the body. Force is required to change the momentum of a body, either to increase the momentum of a body or to decrease the momentum of a body. Force is essential, and the force which is required is directly proportional to the change in the momentum of a body, which means if you expect a greater change in momentum of a body, then the force has to be applied in greater amount. If you need a very less change in momentum of a body, the force required would be less. In case of a bullet which moves at very high velocity, has got greater momentum, the force required to completely stop the bullet would be greater. And the second important observation is the force required is inversely proportional to the time taken to change the momentum of the body. If you try to understand a man catching a ball, the man has to drag his hands in order not to get hurt. Why he has to do so? If he drags his hands, he is increasing the time of contact. He is increasing the time taken to stop the ball, which means the force applied on the ball by the man is less because he is doing so by taking more amount of time such that he will not get hurt. Based on these two important observations, Newton's second law of motion is stated as the force applied on a body is directly proportional to the rate of change of momentum of the body. And the simplest mathematical form of this statement is F equals m multiplied by a. The net force equals the mass of the body multiplied by the amount of acceleration produced in the body, which means if we apply force on a body, then the force applied must be equal to the mass of the body on which the force is applied multiplied by the acceleration produced in the body. And the force here is measured in newtons, and the mass is measured in kilograms, and acceleration produced is measured in meters per second square. The more force, the more acceleration. Here, a man is applying force F on a cart. Let the acceleration produced in the cart be A. If the man doubles his applied force, now the force applied is 2F, and in this case the acceleration has to be doubled according to Newton's second law. Hence, the acceleration produced in the cart nav is 2 times the acceleration produced earlier. So, the more force, the more acceleration on the body of same masses. The more mass, the less acceleration. Here, a man applies force F on a ball of mass m1 and produces an acceleration a1. If he applies the same amount of force on a car of mass m2, that should produce an acceleration a2. Since the mass of the car is by default greater than the mass of a ball, acceleration produced in the car is less compared to that of the acceleration produced in the ball. Hence, the more mass, the less would be the acceleration for the same amount of force applied.